Okay, here's some more with section 2.1, limit algebra. Okay, or those limit properties that we know and love. This is all coming from proposition 2.4. Now they do it a little bit differently, I guess, than I would, but so for instance, let me do if the limit as z goes to z naught of f of z is equal to, say, little w, and the limit as z goes to z naught of g of z is equal to big W, then the limit as z goes to z naught of f of z plus g of z exists, and it's equal to w plus big W. Okay, and now, so for the proof, if you use the epsilon delta, well, since the two limits exist, then given epsilon, okay, greater than 0, we can find a delta 1 such that, now I'm not going to use epsilon, I'm going to use epsilon over 2, so such that the absolute value of f of z minus little w is less than epsilon over 2 when z minus z0 is less than delta 1. Okay, so that's just our definition of a limit. And we can find a delta 2 such that, and so same sort of thing, but for g, such that g of z minus big W is less than epsilon over 2 when z minus z0 is less than delta 2. Okay, so now if you take the two of those together, you've got, so f of z plus g of z minus w plus big W there. Well, that is equal to the absolute value of f of z minus little w plus g of z minus big W. So you've got that, but that's less than f of z minus w in absolute value plus g of z minus w in absolute value. So that's that triangle inequality. But then that is less than epsilon over 2 plus epsilon over 2, which equals epsilon, when z minus z0 is less than delta equal the minimum of delta 1 and delta 2. So there you go. So that's the idea of using the definition to prove the sum of the limits is the limit of the sum, and So that's just getting, more formal. Okay. We actually have a nice proof using our epsilon delta stuff there. Okay, so that's the proof of the sum. And then you could work on similar things. We've got that the limit of c times f of z as z goes to z0 is equal to c times w, where that w is that limit. We've got the product, right? The limit as z goes to z naught of, say, our f of z times g of z is that small w times the big W. And the limit as z goes to z naught of f of z over g of z is equal to our little w over big W, provided the limit as z goes to z naught of g of z is not equal to 0, or in other words, that big W is not equal to 0. So those are our limit laws that we know and love, and so those are just like what we had in calculus.